Whether a variable is qualitative or quantitative, or continuous or discrete, it is also important to consider the variable's level of measurement. In order to determine the level or scale of measurement, we again need to consider the operational definition. That is, we need to define the variable in measurable terms. For instance, the variable, happiness, can be operationalized in many ways. Perhaps people are asked to choose among three statements. I feel sad. I feel neither sad nor happy, or I feel happy. Or maybe researchers decide to count the number of times a person smiles as a measure of their happiness. A variable's operational definition determines the set of values the variable can take on. For the first measure of happiness, there are three values: sad, neutral, and happy. For the second measure, the values are 0, 1, 2, and so on. The set of values and whether and how they are arranged along an underlying dimension determine the level, scale of measurement. There are 4 levels: nominal, ordinal, interval, and ratio. The scale of measurement constrains the kind of statistics we can use with a variable, so these distinctions are important. The values of a variable that is measured at the nominal level are mutually exclusive, unordered categories. The categories are denoted by names or labels or codes. Some possible nominal level variables include favorite social media platforms, religious preference, and country of birth. The values of all of these variables are labels or names. The values are mutually exclusive, which simply means that only one of the values fits any given observation. If a person was born in Egypt, they cannot also have been born in Indonesia. The values also are not ordered in any way on the scale. Argentina is not more or less a country than Ecuador. The values of a variable that is measured at the ordinal level are mutually exclusive, but do have an underlying order. If we rate student performance in a course as outstanding, good, fair, or poor, we know that someone who was rated as outstanding did better than someone rated as good, but we cannot assume with an ordinal scale that the spacing between values is equal. The distance between outstanding and good may be greater or smaller than the distance between good and fair. We don't know because the distance is not defined as part of the scale. On an interval scale, values are mutually exclusive. They have an underlying order, and the increments between values are equal in size. What an interval scale lacks is a true 0 point. Instead, the 0 point on an interval scale is chosen arbitrarily. The classic illustration of interval scales compares the Fahrenheit and Celsius temperature scales. The values on both scales are equally spaced, but 0 is in a different place, well below freezing for Fahrenheit, exactly at freezing for Celsius. One way to think about whether or not a scale is an interval scale is to ask what the value 0 represents. If 0 is a true absence of the measured variable, then the scale is ratio. Many shoe sizing systems use arbitrary 0 points, so they are interval measures. With shoe sizing, we know that a size 0 does not mean the shoe has no size. 0 is just a label for one particular size. Finally, the values of a variable that is measured on a ratio scale are mutually exclusive, have an underlying order and equally spaced intervals, and also have a true 0 point. Physical quantities like height, weight, and time are ratio measures. This does not necessarily mean that you must observe a value of 0 in your data, just that a true value of 0 is on the scale.